All right. This is our geometry review 1 through 40 review, part 2. Okay, question number 16. It says find measure angle K. What that tells me right off the bat is that I'm going to solve for x, and then I'm going to use that value for x. I'm going to substitute in for that value in for 6x minus 9. So if I find x, x will probably be in here somewhere. Okay. What this question should show us, there's actually two different ways to solve this. The easy way to solve this is to know that this is the exterior angle, and that with an exterior angle and a triangle, that the two remote interior angles, if I add those up, will equal that exterior angle. How many of you solved it that way? One or two, okay. You could also say that 4x plus 7 plus 6x minus, well, you could find this angle by subtracting 118 from 180, find out what this is, and then add this, this, and this up, set that equal to 180, solve for x, okay? But what's a fair bit easier is to do 4x plus 7 plus 6x minus 9 equals 118. Not 180, but 118. Just those two angles added up will equal this outside angle here. Okay? All right, so from here, what do we do? Combine like terms. Give me some like terms, Tatum. Which is what? Okay, so she says 4x plus 6x is 10x. Any other like terms? 7 and 9. What do you get from 7 and 9? The 9 is negative. Good call. Equals 118. Okay, Garrett, what would you do from here? Add 2 to both sides. Okay, so I got 10x equals what? 120. Caden, what would you do after that? Oh. Divide by 10 on both sides. So you get x equals what? 12. Okay. And nice enough that 12 doesn't actually show up as an answer. What do I need to do with 12? Substitute. Substitute it in for what, Christian? Calejo? What do I substitute it in for? What? Yeah, I know. It is 12. What am I substituting 12 in for? What does the question ask? It says find measure angle, not L, right? So, but it's important because watch what happens. 4 times 12 plus 7. Well, 4 times 12 is what, 48? 48 plus 7 is what, 56? So somebody would probably round it down to 55, right? I see that happen a lot. You don't get the answer, you don't get anything that's on there, but you get something that's close to something else, and so you just pick that thing, right? Yep. Okay? So there's a lot of that goes on. So we want to make sure that we're answering the question that's asked. So 6 times 12 minus 9. 6 times 12 is 72, right? Minus 9 is 63. Okay? So we want this right here. Okay? Like I said, there's more than one way to solve this. Do you want to see another way? Okay? So if we're trying, if we have an exterior angle like this, that the two remote interior angles, the two remote interior angles are the angles that are not adjacent to that exterior angle. Okay, we'll real quick look at one, and then we'll start looking at the test questions. 1, tell whether a triangle with side lengths 9, 15, and 12 is acute, obtuse, or a right triangle. Is there a theorem or postulate that I can use to set this up with? Acute, obtuse, or right? Equation, theorem, or postulate. Anything I can use? What did you guys use here? How did you come to an answer? Not everybody missed it. What's that? You graphed it? How did you graph it? Oh, you just don't know? Does anybody have any clues on this? So probably more of us should have missed this, right? Huh? You just drew it out? Okay. And then what? How did you determine if it was acute, obtuse, or right? Just by how it looked? Oh, okay. All right, so there's an actual way of knowing this, okay? So what is the Pythagorean theorem? A squared plus B squared equals C squared. So C is always what to the rest of the triangle? The longest side. So I could look at 9, 15, and 12 and determine which should go in for C, right? Okay. Now, the other thing I want you to understand is, well, okay, so I can tell whether or not it's right, but how do I tell if it's acute or obtuse? Okay. So this is right, and we know this. But A squared plus B squared, if C squared is greater than the sum of A squared plus B squared, it's obtuse. Okay? If A squared plus B squared is greater than the sum, or sorry, the sum of A squared plus B squared is greater than the hypotenuse, then it's acute. Okay? Granted, this isn't going to show up well in the video. Well, maybe I can compare it like this. All right, so let's say I have two lengths that look like this, right? Okay. That would make a right triangle. But let's say that I make that red line longer. Okay? I make it like this. But the two blue lines have to stay the same length. What ends up happening, okay, is that angle has to become wider. Okay, has to become greater. But if the red line is really short, okay, I don't know, pick a different color here. Okay, then you'll notice that it becomes more acute. I'm sorry, I'm not doing a great job here. But I always kind of show this with my hands because I know that my hands are going to stay the same length. Okay, but if I imagine an invisible line between my fingertips, that the longer the line is, the greater the angle is where my wrists meet. Does that make sense? And that the shorter the distance is, the more acute that angle becomes. But if they're, that makes a right angle. As that line shortens, it's acute. As it lengthens, it becomes obtuse. Does that make sense? Okay? So whether or not you keep that image in your head, I don't know. But you do have three formulas that you can look at. So let's put our numbers in. What number do we use for A? 9. Okay, that works. 9 squared plus what? 12 squared. Good. Okay? And we want to see how it compares to 15 squared. So we're not putting anything in between yet. Okay? 9 squared is good. 12 squared is 15 squared is 225. Okay? 81 plus 144. What's 81 plus 144? Is it 225? Okay. So because 225 equals 225, what is it? It's right. Okay. If it's equal, it's right. Now, how do I remember how these work, right? Because they look exactly the same. How do I know which one is obtuse and which one is acute? This is what I'll tell you. If the hypotenuse is big, right? If the hypotenuse is great, it's big, then it's obtuse, okay? The longer that line is, the bigger the angle across from it, okay? If the C is small, then it's going to be acute, okay? So if the sum of the other two sides is bigger, right, it's going to bring that line in. Does that make sense? Okay, so I don't know. Hopefully you can remember that. Okay, so that's as much as what we'll cover from the review that you guys worked out. From here, I'll come over to our document where we're working out some questions. Okay, we made it down to question number 3. Now, this question it's similar ish. Okay, so they're going to give you three measurements. Let's say we've got a measurement of 10, 14, and 20. Okay, 10, 14, and 20. Okay, and the question is can these three lengths form a right triangle? Okay, tell whether the given side lengths form a right triangle. How would I set it up to show work? Okay, Pythagorean theorem, which is what? A squared plus B squared equals C squared. Okay, now what, Garrett? Okay, we want to see if it equals 20 squared, right? 10 squared is what? 100. 14 squared is less than 225. What? 196. And 20 squared is 400. Okay, what's 100 plus, well, what would that be? 296? Okay, is this a right triangle? No, not right. Okay. They're going to give you different numbers on the test. It may or may not be a right triangle. I just want you to know, one, where you're going to use the Pythagorean theorem here. Two, the largest number goes in for C. Okay, and then go from there. Okay. Okay. Let's see. All right. This next question is basically, number 4 is the question that we just did from the test. Okay. So it's the same. It's going to give you 3 numbers, and it's going to say, is this acute, obtuse, or right triangle? Okay. So I'm not going to work it out on the board because we already got that information in this video so far. Okay. So we're going to go on to question number 5. Okay. Let's see. This one, they're going to tell you about a park. Okay, we've got a park, and it has sides that have a measurement. Somebody give me a good triple-digit number. 3 digits, like in the hundreds. 121. All right, so the park has sides that measure 121 meters. Okay, and it's square. Okay, square park. Okay, 121 meter sides. Okay. Now to separate 2 areas, there is a diagonal sidewalk that goes from one corner to an opposite corner. Okay, we want to know what the length of that diagonal line is. Okay, so what do I do here? Draw it. Okay, what am I drawing? Draw a square. Okay, so we know squares have right angles. We know squares have sides that are congruent. Okay, there's a square. Now what? Draw a diagonal. Okay, something like that. Okay, we want to find the length of the red line, correct? Okay, what else? 121 meters. What's next? You see? Do you guys see by now how much of the Pythagorean theorem you're using? I mean, we've done it in the last 3 or 4 questions, it feels like. Okay? What's next? 121 what? Squared? Plus 121 squared equals, okay, 121 squared. It's probably a pretty big number. What's that? Go ahead, John. 14,641. I'm going to bet that it's 14,641 again. Okay, now what do I do? Add them. Okay, so 14,641 plus 14,641. It's 29,282. Okay, 29,282 c squared, right? We want to round our answer to the nearest tenth. So what do I need? Now, Garrett, do I stop here? I have to do the little thingy. Square root, absolutely, square root. And the only reason I pick on you is because we typically stop here, right? I mean, okay, so I'm just trying to make sure, okay, we know to keep going. Square root of 29,282. 171 point what? 0.11. And I said round it to the nearest tenth, so just 1, right? 171.1 meters. I'm going to count on you guys. All the math looks right. Granted, I was up here with the calculator, so if you get, what you gave me is correct, then that's correct. Okay? Okay. All right, let's see what number 6 has. Number 6 is a proof. I'm not going to work it out. By now, you guys should know how to look and read proofs. So just going to, you're not writing the entire proof. You're just looking at what's missing and trying to fill it in. Okay, it's still a multiple choice question. Okay, so you want to look at that closely. If you have questions on test day, I'll try to give you some pointers. Okay. All right, number 7 is a question that you have seen on the review. So it's in your document, and it's one that was covered in the video, probably part 1. Okay. It is asking you to find the area of a sector. So with that, let's see. Let's just write up so that we know in this class, how do I find the area of a sector? Minus or over? Over 360. Very good. Yes, that's the area of a sector. Okay? Good. So you guys should be prepared for that. Are you all right? Okay. All right. I am fairly positive because what the other thing I'm going to try to send to you guys as well is any old review videos. And I'm pretty sure this is covered in an old review video on number 8. Number 9 is in your review. Number 10. Okay, number 10 is one I want to look at. Okay, number 10 is going to give you a list of different equations, and it wants to know which lines are parallel. Which lines are parallel. And those 4 equations are going to be in different formats. So I'll see if I can, let's say we got y equals negative 8x plus 5. Y equals, let's do x plus, x plus 1/3 y equals negative 8. Y equals negative 3x plus 6. And y minus 2 equals negative 1/8 x minus 8. Okay, so they give you these 4 equations, okay, and they want to know which lines are parallel. How do I determine parallelity? How do I know if 2 lines are parallel? They have the same slope. They also have to have a different y-intercept, because if they have the same slope and the same y-intercept, then they're the same line. What do I have to do to these 4 lines to be able to compare them against each other? Put them in y equals mx plus b form. Are any of them already in that form? First and third, right? The other 2 have to be changed, correct? Okay. The fourth one doesn't really need a whole lot though, does it? You need to distribute the negative 1/8 and add the 2, right? Okay, so I got y minus 2 equals negative 1/8 x. What would that be? That would be positive. Would be positive 1, wouldn't it? Plus 1 plus 2 plus 2. So I get y equals negative 1/8 x plus 3. Okay. So we've got this equation down here. What has to be done with the second equation? How do I get it into y equals mx plus b form? Subtract x. Okay, so you got 1/3 y equals negative x minus 8. Now what? Divide both sides by 1/3. Can I divide by a fraction? Multiply by 3, because if I can't divide by a fraction, but I can multiply by what, class? Multiply by the reciprocal. The reciprocal to 1/3 is 3/1. So I'm going to multiply both sides by 3. So I get y equals, what's 3 times negative x? Negative 3x minus 24, right? Okay. Can anybody tell me which lines are parallel? Let's call this 1, call this 2, call this 3, call this 4. Which lines are parallel? We just went over that. How do I tell if 2 lines are parallel? They have the same slope. What's the slope? Not negative 3x. Just what? Just negative 3. So negative 8 is the slope here. Negative 3 is the slope here. Negative 3 is the slope here. And negative 1/8 is the slope there. So the lines with the same slope are 2 and 3. Do they have different y-intercepts? Okay, so I'm going to say lines 2 and 3. You have to show work on this question. I will not take guesses. Do you understand? So granted, 1 and 3, right, if you get 2 equations that are already in slope-intercept form, you don't have to do any work to those 2. But you do have to do work for 2 and 4, all right, and then be able to make a decision. Does that make sense? We know what we're expecting? Okay. All right. Let's see what else we have. Okay, 11 was on your review. Okay, let's look at 12. 12 is going to give you a triangle. It's just, I think, okay. Okay, this says order the angles from, oh, I'm sorry, order the sides. Order the sides from, I believe it's least to greatest, shortest to longest. Okay, so we need to find out what the shortest side is. Is there any information that we need to put on the board before we can determine that? What information is missing? Angle C. I need to know what the degree measure of angle C is. How do I find that out? Okay, so subtract 115 from 180. 65 degrees. So we'd say this is 65. Okay. All right, so what is the shortest side? No, what is the shortest side? AC, good. AC. How did you determine it was AC? Well, I mean, I just drew it up. I didn't measure anything. Why is AC the shortest side? Okay, so listen. The shortest side will always be the side that is opposite the smallest angle. What is the smallest angle up there? B, 51 degrees. What side is opposite of B? AC. You cannot go based upon how it looks because, like I said, I just drew it up there and threw stuff randomly in. Okay, so I didn't, I didn't have some crazy, quick mind there. Okay, so do we understand? Smallest angle, shortest side. Okay, all right. Which one is in the middle? Okay, what side? No. BC. Why BC? Because 64 is the next one up, right? What side is opposite of angle A? BC, right? Do we get that? Okay, the largest angle is what? No, angle. What's the largest angle? C. C. So the side that's opposite of C is AB. Do we get it now? The shortest side will be opposite the smallest angle. The longest side will be opposite the largest angle, always. Okay? And that's a principle that we've used in other questions, right? I want to say it was like maybe number 7 in your review, right, where you had to find that range of values. Okay? All right, let's see what else we got. Okay, and I'm only going to cover as many as I can cover. Whatever we don't get covered, all right, so they're going to give you some measurements and they're going to ask you, could this form a triangle? And you have to prove this with work because the answer is a simple yes or no, but you have to have work to prove it. I'm not going to take somebody who just wrote yes on their paper. I will count it as a DSA. All right, so give me some single-digit numbers. 2, give me another one. 9 and 4. Okay, 2, 9, and 4. Can 2, 9, and 4 make a triangle? How do I determine this? Does anybody know what the rule is? Okay, so here's the rule. This is what you need to know to be able to answer this question. Any two sides have to have a sum greater than the third side. Okay? So, let's pick two sides. Side what and what? Side 9 and 2. So 9 plus 2. Is 9 plus 2 greater than 4? Okay? So yes, good. Okay? Another two sides. 2 and 4. Is 2 and 4 greater than 9? No. Okay? So no. All right? And then you can do the third one if you want. What would that be? 4 plus 9? 9 and 4 is greater than 2. Yes. But because of this, the answer is no. Those links cannot form a triangle. Does that make sense? Okay. Now, you guys picked those numbers randomly, so don't count that it's going to work out exactly this same way on the test. But this is how we figure it out. Okay? What time are you guys out of here? 57. Okay. This next one, it's pretty similar to that. Let's see. Give me some 3-digit numbers. Some numbers in the hundreds. 130 and 165. Okay. So let's say that we've got 3 cities. I don't know, we're just going to pick, let's say, Kansas City, St. Louis, and Kirksville, right? Isn't that roughly how they're situated? Not really, but here, let's do this. Let's make this would make more sense if it was Columbia, right? Okay. Now, so based upon this triangle, we need to find out the range of values that are possible for the distances between Kansas City and Columbia. Okay, now remember, in the last question, we said that any 2 sides have to add up to be greater than the third side, right? Okay, so let's call this x. So let's write some inequalities, right? Just like what we wrote on the other one. So how would I set this up? Has to be greater than x. Now, we can simplify that, right? What's 130 plus 165? Wasn't that like 295? So that means x has to be less than 295, right? Okay. Now, what else? The other one that I would use is pick the smallest side, which is 130, and say that plus x, that's going to have to be greater than the third side, which is 165. Okay, now subtract 130. Okay, so x has to be greater than what, 35? What's that? I got it right? Okay. So that's how this works. There's my range of values. X has to be greater than 35. Otherwise, 35, if it was just 35, right, 35 plus 130 wouldn't be greater than 165, right? So it's got to be something greater than 35 miles, okay? Does this make sense? Okay, because you're going to see this on Monday or Tuesday. Did I say Tuesday? Okay, Tuesday. Yeah, because we're going to SMART goal test on Monday. Okay, so you add up the 2 known sides and set them greater than the unknown, and then you add the smallest one to our unknown and set it greater than our largest known. Okay? The next one is pretty much the same thing. It just doesn't give you a visual. It tells you what 2 sides of a triangle are, and again, asks you to find the range. Do we need to do that again? Do you guys understand it, or do you want to work with it again? Yeah. You get it? Does anybody not get it and they want to see it again? Okay. This question on the test is going to work with just single-digit numbers as opposed to triple-digit numbers, but it's not going to give you a picture. All right? So that's 15. 16, I believe you saw this one on your review, so we don't need to do that. Okay. All right. This one you've seen before. It's going to tell you that, what is this, 17? 17 tells you about a parallelogram. Let's say it's QRST, something like that. Okay. They're going to tell you what measure angle R is. I'm going to say angle, not angle Q, angle R equals, I don't know, 98 degrees. Okay. We want to know, what does angle T equal? Well, let me change that. Let's say angle S. What is angle S? Let me fix this. Angle S equals what? So, I think I heard somebody say, do what first? Draw a parallelogram. How do I draw a parallelogram? Draw a rectangle? Well, a rectangle is a parallelogram, and so is a square. Okay, but typically I draw them, if they're just saying a parallelogram, I don't want to draw something where I'm going to think rectangle. Okay, because also notice this, angle R is 98 degrees. In a rectangle or a square, what are all the angles? 90 degrees. All right, now what do I need to do now that I've drawn a basic parallelogram? Label. Where do you want to put Q at? Okay, where do you want to put R? Okay, Q, R, S, T. Okay? Okay, R is 98 degrees. We want to find S. Okay, so I have to know my properties of quadrilaterals or parallelograms. What do I know about? Would you call R and S, would you call those consecutive or opposite angles? Nope. Consecutive. Opposite, R and T would be opposite. Okay, S and Q are opposite. Okay, so the rule that I need to know here is that consecutive angles are supplementary. Consecutive angles are supplementary. Okay, consecutive angles are supplementary. What does that mean? They add up to be 180. Very good. So 98 plus X equals 180. Okay, so 82 degrees. Okay, does that make sense? They're not going to give you the picture. All they're going to say is here's a parallelogram. This angle equals this. What does this angle equal? Okay, so you have to draw the picture to find out what the relationship between the angles is. Okay, if they are opposite, then they're congruent. So if they had asked me for angle T, I would have said 98 degrees because opposite angles of a parallelogram are congruent. Okay? Consecutive angles are supplementary. Let's see. What do you say, guys? You guys said 57? So I got 4 minutes. 3 minutes. They're going to show you two triangles. They're going to tell you that two angles are congruent. They're going to ask what an angle equals. 19. They're going to give you a line in slope-intercept form. They're going to give you a whole bunch of other lines in different forms, and they're going to ask you which line is parallel to the other line. So it's really, really similar to question 10 that we looked at. So if you can do question 10, you can do this. And question 20. Question 20 is another proof, but it's really pretty easy because it's just math that's being done. And what you need to figure out is what do you call those steps? What are the justifications for those steps? Okay? That's about as much as I can give you. Again, what you should realize when you're taking the test is that there's probably 5 or 6 questions on the test that come straight off of your review. Okay? I understand that there's some proofs and there's some questions that we haven't talked about. And if we have time on Monday after your SMART goals, then we might take a look at some of those things. Okay? All right, I'm going to stop it there.